Hi, welcome to our exponents and logs unit. And we are starting out with just a quick review. I do think this will be quick. We'll find out. But we are just in this video reviewing how exponents work. And this is often a little tricky for people. There are a lot of kind of procedural rules. And these rules just help you to have flexibility as a mathematician, because there are times that writing an expression a certain way can help you. And so you want to be able to adapt and just kind of move things around, but move them in ways that are mathematically legal. So I'm going to start out with having you just try these 8 properties. These are all written in general form. So we used the variables a and sometimes b for the bases, and we used the variables x and y and the numbers 0 and 1 as exponents. I would like you to take approximately 2 minutes and write down what you think each of these are equal to. It does say at the top you can look up rules or ask friends, and so if you are, like texting with a friend while you're doing your homework, or if you have, an older sibling around, you can ask people things. But if you do, I would ask that you then circle that property, because that means that you didn't actually know it yourself in your own head. Okay, and this can be an indicator of which things you need to practice. So take 2 minutes, write down what you think each of these 8 things are, and then come back to the video. All right, hopefully you follow directions. I'm always very nervous about that. I hope you guys follow the directions and don't just barrel ahead. But these are the answers that you should have. And I'm just going to mention each of them in turn, just because I think it's important for you to understand each one. So when we have an exponent in the first place, that means we have repeated multiplication. So a to the x means I have a times a times a, x times. And then a to the y means the same thing. I have a times a times a, y times. And so if you think about those in combination, that means you have a x plus y times. Now, I know I will confess that as a student, I had a really hard time remembering this property. I got it confused a lot with this one down here. So what I would do, and I remember this specifically from my Algebra 2 class, is I would write down these 2 examples. And I would think, okay, x squared means x times x. X to the third means I have 3 x's. So altogether I have x to the 5. So then I could see, 2 and 3 make 5 if I add. Okay? Whereas down here, skipping ahead, just to, honor young Mrs. Lemke. So 2 times x, if I have x cubed twice, I have x to the third times x to the third, and as we just talked about, I'm going to be adding these exponents when I'm multiplying. And so then I would say, if I have a power to a power, that's when I multiply. So here, that's why I multiply the x and the y. So I just mentioned that in case any of you have the same little hesitation that young me had. All right, the next one, you have a to the x divided by a to the y. You're going to subtract. Again, you could come up with an example, and say if I have x to the 5th over x squared, this means I have x 5 times on the top. I have x twice on the bottom, and then this makes a 1 and this makes a 1. Okay, so if I have x to the third, that means 5 minus 2 would give me the 3. Okay, a negative exponent is switches things upstairs and downstairs. So if I have a to the negative something in a numerator, which this is, then it is without that negative sign, but in the denominator. Okay, and understand it's the exponent that is changing sign, not the whole shebang. Okay, a to the 0 is 1 as long as your base isn't 0. If you have something like 0 to the 0, as you will see in calculus, that is a whole different ball of wax. That's an indeterminate form. That's for later. Okay, if you have a product to a power, you can take each part to that power. Similarly, if you have a quotient to a power, you can take each part to that power. And a to the 1 is just a. Okay, now with those properties, you should be able to handle these questions. Okay, if at all possible, I would like you to not touch your calculator. Try to just work on your computation skills. If you do need to use your calculator, that's all right. I'd rather that you get the question done. But do try to, challenge yourself in that way. Again, I'd like you to pause the video and then come back when you're done with this. It will take you longer than just writing down those properties did. So maybe like 5 minutes or so. Work all of these problems to the best of your ability and then come back to check. Okay, so I had a hard time fitting all of my solutions in this space, just like to show my work neatly. And so you can see that there are 4 questions that I wrote next page on. So we'll come back to those. So I'm going to go a little out of order. I hope that's okay with you. So the ones in green, kind of like every other question, I'm just going to make a comment about each one. I'm not necessarily going to walk through each one, but here you're multiplying, so you add the exponents. Okay, and then remember how you add fractions, and 9 divided by 3 is 3. Okay, in C, I'm going to do every other one, then come back. This negative exponent means I can switch it from being in the denominator to being in the numerator. Okay, and you might say, well, why is that a numerator? Well, I could write this with a 1 on the bottom if I wanted. And then the square root of 16 can be written as this with a radical sign, but it also is this. Okay, and so you hopefully remember from your algebra class that when you have a fractional exponent, this part on the bottom is a root, just like roots are at the bottom of a tree. Okay, so that is a square root of 16 to the first power. Okay, so square root of 16 is indeed 4. In E, I first utilized the idea of a power to a power, as well as the idea that this exponent could go with both the top and the bottom. So a power to a power, I'm going to multiply. 4 times negative a half is negative 2, and I can put that with both parts. Negative exponents switch numerator and denominator, and then the exponent is positive. So I'd have 5 to the positive 2 on top, 3 to the positive 2 on the bottom, and then just work that out. All right, these parts down here get a little bit more sticky in terms of roots. So remember that comment that the number on the bottom is the kind of root if you have a fractional exponent. So this is indicating a square root. If you jump ahead to J, the 3 on the bottom here means I have a cube root. So what I did first is just dealt with the square root, and then I saved this 3 right here to just deal with later. And so I took the square root of everything inside, and then each part to the third, 6 to the third, c to the third, right? Power to a power, you multiply, and then d to the 6th to the third gives you d to the 18th, okay? As far as taking the square root part, remember that square roots can be written as to the 1/2, okay? So if you're working on the part that came previous to this, c to the 6th to the 1/2. So half of 6 is 3. Okay, and then J had a little bit of a twist in that, first of all, I was a little tight on space, which is not a good reason to not show your work. Don't do that. But here I had m to the 2/3, and then that was squared. So there was a little like side thought here that m to the 2/3 squared would be m to the, remember you have to multiply here, so 4/3. That's 1 1/3. So the 1 came out, and then the leftover third is still in the root. Okay? On this page, I had the other questions, the alternating questions, just for space sake. And these 3 all seem to me a little more straightforward, which is kind of nice. So here I have a power to a power, so I multiply these. I got to the 1/3 power, because the 4s would cancel. And so that's the cube root of 7, or 7 to the 1/3 would be a fine answer also. You can see my answers for D and for F. I think those make sense, right? You have to remember here how to add fractions, right? 1/6 and 2/6 make 3/6, which is a half. And then this bottom one is just a little spicy because I think most of us don't love fractions so much. You should try to love fractions. Fractions are your friends. So here, in this bit, I would subtract the exponents. Here I would subtract the exponents, and here I would subtract the exponents because I'm dividing with each of those, okay? And you line up the things that have the same base, and then all of that comes out pretty great, okay? Now, as a fun little bonus at the end of these notes, there is a puzzle, which is great, and I love jokes. So, have you ever heard of the planet Saturn? What did the professor say when asked, have you ever heard of the planet Saturn? I do not know what he said. I'm very curious about that. So I would like it very much if you would take the time to work this puzzle, come back at the end, and you can see if you're right. Though you should know if you're right if it makes sense, right? If it spells like gobbledygook, you're kind of got a mistake somewhere, okay? So riddles are somewhat self-checking. But try these problems, and then you can come back and see what's up, okay? Pause the video for a minute. Well, more than a minute. Let's be specific. Pause the video for a little bit while you do the riddle. Okay, friends. This is what I got on the first part. You can double check. So the part to the left focused on working with the numerical expressions. The part on the right focuses on working with the algebraic expressions. Okay, are you ready for the big reveal? Have you ever heard of the planet Saturn? I'm not sure, but it has a familiar ring. Oh my gosh, that is a real knee slapper. That's amazing. Okay, feel free to pause over any of these joke solutions and find any mistakes that you had and try to figure out what math went wrong, right? That is how we learn, figuring out what mistakes we made and why. Okay, and if you made no mistakes, well, good for you. Awesome job. All right. So go look up some facts about Saturn and share them in class. Okay, I'll see you later. Bye.